There is this pattern in the Zig programming language that has made an appearance, maybe in other languages too, but I first found it in Zig, and it's called the diagnostic pattern. It's interesting. I first used it with clap, and you know what? Let me just go ahead and pull that up. Okay, so I've got this project here, and I first used the diagnostic pattern with clap, but to be completely honest with you, I didn't really understand why I was doing this. Probably a faux pas on my part, something I should have looked deeper into. But with clap, you have diagnostics that you can pass to it here. It takes in a pointer. Totally don't need to do this. But the idea here is if something goes wrong, we can provide additional information about what went wrong via writing to the diagnostic memory space. So this is a really interesting solution to a really interesting problem because we're parsing something and there can be an error or it can succeed. And in both cases, there could be diagnostic information about what was parsed that we may want to act on. In the case of an error, we do diag report. So we call report on the diagnostic and then report using a writer, in our case, the standard error writer. And, we just catch that in case it fails. But this pattern is really, really nice. And I'm bringing it up today because this project you're looking at is HTTP spec. It is a small extension to the HTTP specification, the file HTTP file specification, that adds assertions to the file. And this is a tool that runs those as tests. So it'll run the HTTP request and then check the assertions against the response and then continue down the list of assertions. You don't need to know too much about that. Although I'd love it if you checked out the repo, and I'll put a link to that in the description below if you'd like to see more. But there's a couple key things here, and it really boils down to 3 different parts. So the very first part is that we discover all of the HTTP spec files to run, and then we kick off a thread pool with the reporter. I'm using spawn wait group here, and you can see there's a reference to the wait group. We call run test, passing the allocator, the reporter, and the path to the file. And that calls run test down here. And there's an arena allocator that we create. Without going too into details on the arena allocator, it's just for easier cleanup. But the part that gets interesting here is we parse the file. And then we create an HTTP client, execute all of the requests. So for each of the owned items, which maybe isn't the best name, but for each item that we have from our parsing of the file, we execute the request, and then we call assertion checker check. This is the part that has been bothering me about this. This feels bad. Why does this feel bad? So we call assertion checker check on the owned item and the responses. So the owned item in this case is the parsed HTTP spec. And then the, this actually should just be response, not responses. So let's maybe clean that up really quick. And I'm going to make the text a little bigger. Oh, maybe. Okay, hopefully that is more legible. But the idea here is that we are checking that the response meets the assertions in the owned item. If there's an error, we catch, indicate that there's a failure, and then we break. We don't need to continue. And then if we have a failure, we increment the failure case. And if we don't have a failure, we increment the pass case. I'm just going to flip this because that feels bad. So let's say if has a failure, else test pass. Clean up a little bit as we go. Do the Boy Scout rule. Okay. So let's talk about this. This right here is a problem, right? Because what if we want to know why it failed? There's a lot going on here. We look at the assertion type that you have, and if it is checking a status, it can check a status, it can check a body, it can check headers, the values on headers. It can do an equal comparison, it can do a not equal comparison, it can do a contains comparison, it can do not contains. It's pretty flexible, and the idea is for this to keep growing. So how do we handle the case where, like, I want to tell you what part failed? Because, for example, you might have a test that looks like this, and this one compares the status. But maybe you also want to compare the header, content, type, and you want that to be equal to application XML. something like that. In this case, it would fail on this one first because this is a 404, but if we change this to 403 and it gives us a 403 like we would expect, this would pass and this one would fail. So what's the solution here, right? Well, the solution is that diagnostic pattern that I just talked about. So what we are going to do today is implement the diagnostic pattern for the assertion checker so that we can provide more information about what specifically failed. I don't exactly know where the best place to put this is going to be, so we're going to throw it all up here at the top of this file. I'm going to start by destructuring out a couple references that I know we're going to need. Standard mem allocator. And we also are going to use the array list quite a bit. That's going to be standard array list. And we don't necessarily need to provide it a comp time type at this point. Okay, cool. That looks good. I probably will clean up other things that are using std.mem.allocator to just use as allocator, and same with ArrayList as we go, but we'll see. I've started programming more towards this pattern, and I like this a little bit better. Anyways, let's continue. So we can fail our assertions for multiple reasons. So the very first one is going to be like mismatch on the status or mismatch on the headers, or maybe a header is missing. So what we can do is create an enum here. So we'll call this failure reason. It's an enum. And then we want to add all of those types. So we have status mismatch, we have header mismatch, header missing, body mismatch, contains failed maybe. So a case where like we're trying to see if something contains something but it doesn't. Conversely, we'd have not contains failed, invalid assertion key. This one's important. That's actually kind of hard to troubleshoot otherwise. And then we might have like a format error, and I don't know, we may have more, but we'll just leave it with this for now. Okay. So we have our failure reasons. I'm also going to create a struct here called assertion failure. And this is going to be a struct, like I just said. Oops. And we need to give this some fields. So we're going to do assertion key. It's going to be a slice of const u8. We're going to do assertion value, const u8. Reason is going to be a failure reason. That's where we will use that enum. And then I want to tell you specifically where in the file, or which file is having that issue. So we can do source file here. We can make it optional. There's maybe a case where like we might take something from standard in and there might not be a file. So I'm going to make it optional in this case. I think at this point, everything that I'm doing is actually reading from a file. We don't have anything like that. So we'll probably implement it as if it was not nullable, but as for the actual definition here, we'll make it nullable and we'll just handle that case. I'm also going to add an assertion index. So this will be the index in that file as to where it's located. Okay, I'm going to add some methods here. We're going to call a deinit method. It's going to take in self, which is going to be a pointer to assertion failure. It's also going to take in an allocator. Here's where we'll use that destructured allocator type, and it will return void. This is a pretty standard deinit method that we're working with here. So we'll call allocator.free, and I'm going to have it free everything that it's really holding on to in our case. So assertion key, allocator.free, self.assertion value, something like if self.sourceFile, get a reference to the file there, do allocator.free on the file. I think we need to add a couple more types here to really make this complete. We have the assertion key, we have the assertion value. Let's add assertion type, http parser.assertion. Make sure that's correct. No, we want assertion type. So we'll make this public as well. Assertion type. Okay, I like that. Okay, so we have our assertion type. Maybe the expected value is going to be useful here as well. Not sure how I forgot that. And then the actual value will be useful as well. We have our reason, we have our source file, we have our assertion index. Okay, I feel pretty good about that. So let's go and update our dinit here and also free those new values that we added. So self.expected, allocator.free, self.actual, I think was the other one. So now we've got our dinit method. And this is just going to represent a single diagnostic item. So maybe what we should do now is create another struct. This one's going to be assertion diagnostic. And it's going to be a struct like we just said. This is going to have a list of failures. In fact, it's going to be an array list of assertion failure. It's going to take in an allocator just to make things simple for now. And I think that's really it. We'll create a couple functions on it. So we'll start with an init. It's going to take in that allocator, and that's going to be an allocator. And of course, this is going to return an assertion diagnostic. We can return failures is equal to array list assertion failure dot init with that allocator. And then we need to add the allocator as well, allocator. Conversely, we'll go ahead and add a public dinit method. This is going to take in a pointer to the assertion diagnostic. And it'll return void. This will be something like for self.failures.items. Get that reference to failure to work with. And then do failure.dinit allocator. Sorry, this will actually be self.allocator. And then right here, we'll do self.failures.dinit. So we'll clean up each of the individual assertion failures, and then we'll clean up the list itself. Okay, we are making some headway on this. We have a couple more things that we need to do. So we also need to add failures and have an indicator of whether it has failures. So let's create a function called add failure, and this will probably be the meat and potatoes of this. So if you get through this part, everything else should be smooth sailing. So we have our assertion diagnostic that we're adding to, and then we're adding an assertion, which is going to be an HTTP parser.assertion. We have our expected, which is going to be a slice of const U8. We have our actual, which is also going to be a slice of const U8. We have our reason, which is going to be a failure reason. What are we missing? Oh, our index, our assertion index, which is going to be a usize. And then our source file, which, as we mentioned previously, maybe will be a slice of const U8. This is not going to return anything, except it will potentially return an error. So we'll go ahead and do an error union for the return type. And we need to go ahead and create the failure. So this will be an assertion failure, like so. We have an assertion key, which is going to be, we're going to start doing some duplicating here. So we'll do try self.allocator.dupe. This will be a U8. And it's going to be assertion.value. Sorry, that's not true at all. It'll actually be assertion key. This one will be assertion value. So try self.allocator dupe U8 assertion.value. Next, we'll handle the assertion type. So that will be assertion type, like so. Then we'll handle the expected. So this will be try self.allocator.dupe. We're duping a U8, and this will be expected. We need to also get the actual, so that'll be try self.allocator.dupe. Again, a U8, and this will be the actual. We have our reason here, which gets passed in. That's our failure reason. And then what else are we missing? The assertion index, which is going to be the assertion index that we pass in right there. And then I think our last one is source file. So source file will be something like if source file file try self.allocator.dupe. It's going to be a U8. It'll be the file. Else null. Once we've created our failure, we need to append it. So what we'll do is try self.failures.append, and that item will be the failure that we're passing in right there. And I think that should take care of adding the failure for us. So that's a pretty meaty method signature right there. But hopefully, once we kind of wire this up, you'll see that it's not too bad as for how it's used. So our next one is indicating that we have failures, and we're also going to go ahead and add one that helps us report those failures, similar to the clap diagnostic that we looked at previously. So we'll create one called has failures. This one will be really straightforward, I think. Diagnostic. It's a weird word. And it's going to be an assertion diagnostic. And then, sorry, we don't need a writer for this one. That would be for reporting failures. This is going to return a Boolean, and all this is going to do is return diagnostic.failures.items.length is greater than 0. I think that should take care of it. Now we can go ahead and write our report failures. So we have a pub function report failures. It's going to be diagnostic. I just spelled it. And it'll be const assertion diagnostic. Okay. The return type here will be a void error union. So this one's going to be a little interesting. There's actually going to be quite a bit here. It won't hurt my feelings if you fast forward through this. I don't blame you one bit. I would probably do the same. So for this one, we're going to start with a for, do diagnostics, failures, items, and essentially what we want to do is bind to that failure. And we're going to take a look at that failure and figure out how to report each of them specifically. So we have maybe source info here. So this will be something like if failure.sourceFile, and this is a file, oops, try standard fumped alloc print, diagnostic.allocator. Need to give it a comp time format for something like in SD. And then for the args here, what we're going to do is we'll pass in file, and then we'll pass in failure.assertion index. And I think this is going to be off by 1, so we're just going to go ahead and add 1 to it as well. So we can add an else followed by another try here. And then do standard fumped.alloc print, pass in our allocator. Oops, sorry, pass in our diagnostic.allocator. Just do something like assertion, and then maybe like a number. And then for our args, we'll do failure.assertion index +1. These numbers may be off. We will troubleshoot them as we go, I guess, and adjust them as necessary. Okay, that's a lot in one line. Maybe there's a better way to do that. I'm actually positive there's a better way to do that. It seems to work and not have a fit with the LSP. So we're just going to continue for now, but that seems like something we might want to clean up. Okay, let's defer diagnostic.allocator.free, and that'll be source info. We're going to switch on the failure reason. And if we have a status mismatch, I guess we don't really need those. We can instead do try writer.print. Something like fail s expected status s got s \n. We need to give this what? Source info in our case. Failure dot expected and then failure dot actual. So something like that. We don't have a writer in scope, so let's go ahead and add one before I forget. So up here at the top of report failures, we're just going to add a new type, and that's going to be a writer, and it's going to be an any type, unfortunately. But that's a topic for another time. Okay, so let's handle our next case. So we have status mismatch, we have header mismatch, and this one's actually going to be pretty similar. So I'm just going to go ahead and copy this. And this one will be something like fail, s expected, header, something like \s, to be, yeah, something like that. Expected header, content type to be application JSON, got application XML. Okay, so we have this report failures function. This looks sloppy, but it is what it is. We will go ahead and wire this up now, right? So if we come down to our check method, we can see how check is being used. Apparently only in our tests, which is a little weird. If we go back to main.zig, we can see that assertion checker.check, really weird, is being used like this, and we want to be able to pass in the diagnostics to check so that we can actually do things with those diagnostics. So in our case, we're still going to get the HTTP request. We're still going to get the response from the HTTP client, and then we want to add diagnostic, and this is going to be a pointer to an assertion diagnostic. I think we also need to add the source file because I don't see it in scope anywhere, which is maybe one more thing that I should clean up at some point, but that's okay. That's a problem for another day. So now that we've added our assertions here, I think what I'm going to do is pull this out to another function. So let me just go ahead and create a signature for that. So we'll do something called check assertion, and it'll take in an assertion, which is going to be an HTTP parser dot assertion, a response, which is going to be a client dot HTTP response, and then the diagnostic, which is going to be an assertion diagnostic, the assertion index, which is going to be a usize. We'll have to pull that out. And then a source file, which is going to be maybe a const u8 slice. Okay. The return type on this is going to be an error void. And the whole reason we're doing that is to remove the error void from this method here. This check should not return an error. It should always succeed some way, shape, or form. And to do that, what we're going to do is essentially we will take all of this, we'll move it up here, and then we will write an implementation that references this elsewhere. So we should be able to just grab this, paste it up here, and shockingly no errors. We do have an error. Looks like request assertion items is not defined. That is A-OK. I think we'll sort this out as we go. I don't think we need to pass that in. I think we can actually just handle it down here. So let's figure out what check looks like in this case, right? So check now becomes drastically simpler. All we really need to do, we'll just iterate over it here. We'll do request.assertion.items. We'll get the index as well. We'll bind these to assertion and index. And then we'll call check assertion. We'll pass in our assertion. We will pass in our response. For our diagnostic, we'll pass in our diagnostic. For our assertion index, we'll just pass in index. And for our source file, we'll pass in source file. So much simpler. However, this can return an error, right? So we need to handle that case. So what I want to do is catch any error And I'm going to any error raised, I should say, by a check assertion or returned by check assertion, I'm going to just add a diagnostic failure. And this will be assertion, expected, not applicable, error name, error. Reason will be status format error. The index will be the index, and the source file will be the source file. This too can raise an error, and if it should raise an error, we're just going to catch it. What am I doing wrong? Oh, it's error name, not error name. Okay. Okay, so kind of another interesting benefit of this is now if we run into an error that we're not expecting while doing these assertions, we can catch that error and add it to our diagnostics as well. So how do we actually wire this up? So we have our check assertion method. And if we go up here to our check assertion method at the top, we can clean up a couple things. So the very first thing is that we don't need this anymore because we are doing that in the calling function. We're doing that iteration up a level higher. And then we just want to switch on the assertion type. And then we need to handle each type differently. So what I'm going to do in this case is handle equals. So if standard ASCII assertion key status. So we have our assert status code. It's going to be try. Our response status here. Actually, this video is going on a little while longer than I thought it would, so let me do the magic of editing. Okay, through the magic of editing, we have this updated. So I'm just going to walk you through the key changes here. Really, what happens is we still are switching over everything like before. We're still doing our parsing and our assertions. What we're seeing now is changes where if the assertion is false, we are maybe getting the actual value and handling alloc printing that with the diagnostic allocator. The key thing here is using the diagnostic allocator, so it's also used to free the data at a later date. We're using that actual string. We're adding a failure here, and then handling the reasons, the assertion index, the source file, all of that stuff. So here's another example. So with the body, you can see we're passing in the response body here. Just several examples of calling add failure when something fails instead of returning an error type. So maybe what would be more helpful is if I go in and update some of these tests. I think I'll just update one for this video so you can get an idea of kind of how this will work together. But we have a test here that is supporting starts with for status, body, and header. Testing allocator, an array list that we have for our assertions that we're working with here. Quite a few fairly straightforward things. So what we'll do is we'll come down here to the bottom and where we have our response and we're calling check. What we actually want to do is create diagnostic, and that's going to be an assertion diagnostic. We'll call init. We'll pass in an allocator. In our case, it'll be the testing allocator. And then we can defer diagnostic.dinit to clean up after ourselves. We have our request, our response, our diagnostic gets passed in here. And for the case of our file, since we're not actually reading an HTTP spec file, I'm just going to say test.http spec. What we can also do now is try standard testing.expect not has failures diagnostic. So something like that. Sorry, that's not accurate at all. Sorry, it would need to actually be something like diagnostic.has failures. So something like that. Oop, missing a comma. Okay, cool. Yeah, so this is sort of how that will be used. So now if we go and take this back to our main.zig, what we can do is define our diagnostic struct here in our main.zig. So this should be pretty straightforward. So yeah, I don't know, somewhere like right here maybe. We can do var diagnostic, and this is going to look really similar to what we just did in that test. So it'll be assertion checker, assertion diagnostic, init allocator, defer diagnostic, dinit. We have our assertion checker passing in the owned item, the response, diagnostic, and the path. What's really nice about this is that check no longer returns an error, so we don't have to handle this case. And instead, what we need to do is check if assertion checker dot has failures. Oh, I'm sorry, it shouldn't be assertion checker has failures, right? It'd be diagnostic dot has failures. And then we can do something like assertion checker dot report failures. Oh, same issue again. Diagnostic dot report failures, and it needs a writer, so we'll do standard IO get standard error dot writer. Maybe we can pass that in from somewhere as well, but for now this will work. So something like that. I think in this case we'll still want to set has failure, oh my goodness, to true, and then break as well. So yeah, something like that. Looks like we have maybe a small error. We're not handling a case in the assertion checker on like 85. So let's head to the assertion checker. Somewhere we are not handling that case. So this is header missing, which means we are probably not handling it right here. Yep, that is correct. So we can go here and do header missing, try, and yeah, this is going to be a writer print as well. So it'll be something like fail expected header to be but was missing. Yeah, something like that. Expected actual. Yep, looks good. Okay, let's give this another shot. Looks like we have an unused argument in one of our FUMP strings. Invalid assertion key. Oh, I have assertion key here twice. Small little error. Let's give it another shot. Zig build run. Sweet. So you can see here we actually have our diagnostics working. So it's not pretty, and we can make it prettier, but you can see here that it says fail in link to the test file, HTTP bin test. So let's go ahead and open this. You can see that it's line 1. You can see line 1. Expected 403 got 404. Okay, so this isn't right. Maybe something for us to figure out and clean up going forward, because that's not indicative of line 1. It's actually indicative of test 1. So assuming we have test 0, this would be test 1. So, you know, we can clean that up and make that more clear. Expected status 403. That's what we're expecting right here. But we got a 404, which makes sense. That's what httpbin.org/status 404 is supposed to return. This is intentionally a failing test. Let's flip it just to see really quick what it would look like if we were to flip it. All 1 test ran successfully, pass 1, fail 0, invalid 0. Excellent. Okay, so this video has gone on way longer than I thought it would. I'm going to have to edit it down, but that's part of the job. I think this hopefully covers introducing like the diagnostic pattern into a project in Zig. This is the thing I was missing. So Loris, if you watched this video, thank you so much for reminding me and reintroducing me to the diagnostic pattern, because this is like I just said, exactly what this project needed to really meet its goals. So yeah, diagnostics, CLAP uses them. HTTP spec is going to start using them. We just wrote the code here. I just have a couple things to clean up and then it'll be available. So yeah, hopefully you found this useful, educational, informative, all of the above. If you did, give the video a thumbs up. It helps me, it helps the algorithm, and I'd like to think that that ultimately helps you. If you haven't yet, subscribe to the channel, join the Discord. I'm asking a lot, but I know you can do it. I have such faith in the people who watch these videos. So yeah, I think that covers it. Will I actually clean things up? Will I actually fix more tests? Will we continue to build HTTP spec and more videos? Find out next time on Dragon Ball Z.